Again, thank you everybody for joining us. We really won't get terribly underway until the top of the hour since we've got a lot of people who won't expect to see us till then. Hello, Rosaly.
Hello, you can see me?
I can see you just fine. Thanks a lot. And for a moment there, I saw a friend of yours.
Yes, my little kitty, yes.
Hi, kitty. What's her name?
She's called Miracle because she was the only one from the litter who survived.
Oh my. Okay.
Yeah. I didn't give her the name. The vet gave her the name. But she's been a really good cat. I have 3, but she's the one who likes to get into everything.
Yeah, some cats just have this amazing skill. They know exactly where to go between you and a webcam or any other camera.
Yes.
And so she is welcome to be part of this live event in our member community at the Planetary Society.
Thank you.
Rosaly, if it's easy, I know because I think you're using your laptop, just lean the top down a little bit with the camera and we'll move your eyes up a little bit higher on the screen.
Okay, sure.
And this is all the stuff. There, that's better. That looks great. Okay. And I now have us at 5:59, so we only have to pad here for another minute or so. And in the background, as always, folks, we're going to have the wonderful Amber Trujillo. And I'm just opening up where I will be able to catch where she drops me information about your participation, because of course we are hoping that you will be a participant by sending us your questions and your comments for Rosaly in chat. And I'm going to bet you that if I go into chat now, there's already some stuff there. In fact, here's Amber saying, hi, everyone. Don't forget to leave your questions for Dr. Rosaly Lopes in the chat. And you can also find, and this is something that Amber just excels at, Rosaly, she is going to be dropping links into the chat periodically. Right now, I guess that's your NASA page. So some of the information on that page, folks, her JPL bio page, may need to be updated a little bit, but it's getting there. Here's somebody, Rosaly says, has been a friend of mine for years.
Yes, Jack.
You see it?
Yes.
Hello, Jack. She is a great scientist. We both lived in the same neighborhood in Copacabana, Rio de Janeiro. How do you say it in Portuguese?
We say Rio de Janeiro.
Rio de Janeiro, okay,
yeah.
Which is normally how you hear us Americans saying it as well. So good, I'm glad to get that confirmed. Well, now I've got 6:01, so now I'm going to officially welcome everybody who has joined us so far. I know we'll probably pick up a few more folks as we begin this live Planetary People conversation with the great Dr. Rosaly Lopes, who, as you can see, has already gotten a nice endorsement from an old friend of hers. Rosaly, welcome, and thank you for doing this.
Oh, you're very welcome. And it's very nice to be here. I'm been a great fan and a member of the Planetary Society for many years.
Not just a member, but a contributor in many ways, including, I think I saw that you have been a member of the Advisory Council since 2007.
Probably, yes. I have also written several articles for the Planetary Report.
Absolutely, our great now quarterly magazine. I think you go back to the days when it was bi-monthly, I think.
Monthly.
Monthly, yeah. Well, boy, that may even be before. I don't know, I guess it was monthly when I came on board. I, by the way, am Mat Kaplan, the Senior Communications Advisor for the Planetary Society. And by the way, if you're not a member of the Planetary Society and you're just catching this on our website or maybe on our YouTube channel, well, welcome. We hope that you will enjoy the roughly hour ahead of us in conversation with Rosaly. But we also want to mention that if you join the Society, you can be part of our member community, which now is more than 11,000 strong. That's still just, I think, like 20% of our total membership. And be a part of these events live, where we are now beginning to pick up some information from some of the people who have joined us live. Rosaly, there is so much to talk about. I think I want to go right back to that megalopolis that you hail from, the one where you just confirmed my pronunciation, Rio de Janeiro, and ask you a little bit about your background and how you ended up in this amazing end of science, planetary science and volcanology. Except that I guess if your eyes had been better, you might have been an astronaut.
That's right. I grew up with the Apollo program, and I was totally fascinated by the race to the moon and the astronauts and going to the moon. And I really wanted to be an astronaut from the age of, maybe like 6. And but I also realized that at that time, the only astronauts were American and Russian. There had only been one female astronaut, a Russian. And I was Brazilian, female, and on top of it, terrible eyesight. I have had surgery to correct my eyes, but from the age of 6, I had very strong myopia and wore thick glasses. So I realized, well, that's probably, not going to happen. It would be quite difficult. And my older sister said, well, you could become an astronomer. And I go like, oh, what's an astronomer? But it's something to do with the moon and the stars and the planets I wanted. So I started reading what I could about it. And in Brazil, well, that was before internet, so we didn't have a lot of material available. But I started finding out what I could. And mostly you found out about astronomy from geography books. And I started reading those. And when I was a teenager, Apollo, by early teens, maybe preteen, Apollo 13 happened. And I saw a picture in the newspaper of a young woman called Frances Northcutt. She's known as Poppy.
Yeah, Poppy.
Poppy.
I had her on Planetary Radio.
Exactly, yes. Yeah. And I saw that she was in mission control and read about her, that she was, worked at Johnson Space Center and calculated orbits to bring capsules back. And she had a major role during Apollo 13 because she calculated the way to bring the astronauts back. If you remember, or maybe some of you don't know, but that was the Apollo mission that never got to the moon, that they had a problem and had to come back. I remember I cut that picture and that article from the newspaper, and I kept it, and I thought, yeah, this is my inspiration. And it's very important to have an inspiration when, particularly, when that's not what you're expected to do. There had never been a scientist in my family. My father left school at 14. My mother had a qualification in music. I had a grandmother who was a school teacher. I had some strong women in the family. A great aunt who was a nurse and became director of the first nursing school in Brazil. So there were professional women, but no one was a scientist, or a pilot or anything like that. So it's important to have an inspiration when something seems so far out. But I thought she managed to do it, so maybe I can too. And it's interesting that she then left NASA, and it was many, many years. In fact, at that time when you interviewed her, that we actually finally met in person.
And I remember that now. As soon as we started talking about Poppy, I was about to talk with her at the California Science Center in Los Angeles, and didn't I pull you into that conversation?
Yeah,
because
yes, you did.
she was one of your mentors, one of your heroes, I guess.
Yes.
Yeah,
And
that was great moment. And I see that Amber is keeping right up with us. She has put up a link to Poppy Northcott's listing on the Planetary Society website, planetary.org. And you can easily look up that episode where we got to hear. In fact, there's a great photo of
right.
of the three of us. That was really, it was a very special moment. Yeah, I know you said that your family was very supportive, but as you just said, there just had never been somebody who had gone in the way of science. And I mean, did this come as a surprise? Did they, and I guess if they were supportive, they encouraged you, but I mean, did they have any doubts about your ability in this area? Because I mean, after all, this was still at a time when women going into the sciences was far too rare a thing. I mean, it still is, but it was almost unheard of back then.
Yes, and it's it really was very very different. At first, I suppose up to like my teens, people just sort of used to laugh and think it was cute. And but my father said it's very important to pursue your dream. If you have a dream, go for it. My grandfather thought that the only thing that astronomers did was to discover comets. And he wanted me to discover a comet and put the family name on it.
Uh-huh.
And my sister was encouraging. My mother, once she started realizing that I was serious, she started getting somewhat worried because she thought, how are you going to get a job? Do astronomers get jobs? And but she was very good that she had me learn English from the time I was very young, like 5 years old. Mm-hmm. I went to a course for children, and I learned to read and write in English and Portuguese at the same time. And really, without English, I couldn't have done all that I have done. And, and then, a bit later, she realized I was serious. She said, well, you got to learn French as well. And you have to learn typing. And I didn't particularly like French. It was useful. And I totally detested typing. We still had,
Me too.
Yes. We still typed on machines, typewriters. But in the end, mothers know best because the French was useful, the English was essential, and typing, well, what do we do all day now?
Yes,
We type at the computer, so it turned out to be very useful. But she thought that if I had, those skills, that I would always be able to get a job.
Smart woman. I now thank the middle school teacher or counselor who stuck me in a typing class with manual typewriters, and I hated it. But now I'm a fast touch typist, and thank God for word processing. It made me able to have a career because I type fast, but terribly inaccurately. And so, yeah, isn't that nice that we have that skill now? I was thinking before we go on with, how you got into this, I don't think you ever ended up discovering a comet, but you were listed, at least were, maybe still are, by the Guinness Book of World Records as the discoverer of the most volcanoes by any person. 71, I think. I went into the Guinness website today to see if I could see if that record holds. I couldn't find it, so I'm just giving it to you.
Oh,
you are the record holder. And every one of them on that crazy moon Io, right?
Yes. Well, what happened was it's only in the book in 2006. It's not like something that's always there in the Guinness Book of World Records.
Oh, I see. I see.
Okay. And what happened was very funny. As I was finding more and more of these active hotspots on Io, and I would send email to the team, oh, there's another, 2 hotspots and 3 hotspots. And in one of the fellows on the team, that was the Galileo NIMS, which was near infrared mapping spectrometer.
And the Galileo, that an
That's right.
amazing orbiter that circled Jupiter
That's right.
successfully in spite of some handicaps for
Oh,
many
yes,
years.
we
Yeah.
can talk about those. But anyway, one of the fellows started joking with me, oh, you should be on the Guinness Book of World Records. And then some years later, actually, it was after Galileo had finished in the early 2000s, I had a postdoc who came from England to work with me. In fact, he was working on Titan. And he heard that joke, and I said, yeah, people joke with me all the time because of the 71 hotspots that I discovered. And he happened to have a friend who worked for the Guinness Book of World Records. And,
Serendipity.
and more than that, the guy had started a PhD on Io in England.
Mm-hmm.
But never finished it and went to work for Guinness. So he said, I should tell my friend this. And his friend contacted me and asked for my papers and contacted colleagues of mine, and everything was confirmed. So there is this little note in the Guinness Book of World Records in 2006 about me being the discoverer of the most active volcanoes anywhere. And I haven't actually counted, but Juno has now found, a number of active volcanoes, and I collaborated with a young Italian woman, and and maybe she surpassed my record, but we didn't count. And in any case, I'm still on her paper, so it's a little bit mine.
I think 71 is enough to keep you in the Hall of Fame for a long time. It's just those little tidbits of finding them in your bio and your CV, which, by the way, do you know that that's 30 pages, your CV? All of them packed with accomplishments, published papers, books that you've written, awards that you have received. I mean, as I mentioned here in the community just yesterday we saw the naming of the 2024 recipient of the Carl Sagan Prize from the Division for Planetary Sciences. You received the Sagan Medal from DPS, part of the American Astronomical Society, was it 2005? 2005. And on top of that, you were the chair of DPS,
later,
the Division
yes.
for Planetary Sciences.
Not at the same time.
Not at the same time.
I became chair of DPS. Yes. Yes.
So, the honors go on and on and on and on and on. There was another one that and you can look at the bio, by the way, folks. But I just love this one, taking you back to Brazil, from the city of, is it pronounced Bezerros?
Yeah, Bezerros, yes.
Bezerros. There is a rocket launch site for high school and college students that bears your name, Dr. Rosaly Lopes, which I just think, amid all of these other grand things that you've achieved and the recognition you've received, that just stuck out to me, that there is this spot where young people in Brazil, some of whom may end up engineers and scientists, they're going to remember you because that's where they sent up their first rockets.
Yes, it was a school teacher from that city, and it's a small city, and he contacted me and said he would like to do this, and would I allow it? And I said, sure. And I actually went there. I was going to Brazil to visit my family, so my mother and I went to this city. And this was a while ago, and unfortunately the teacher has passed away, so I don't actually know if the site is still there. But what really, one of the things that really touched me, well, the people were really welcoming, and the land was, donated to them by, they said the wealthiest man in the city. And I met the wealthiest man in the city, and he told me that he started out one of many children. This is a poor area of Brazil in the Northeast. And he only went to a couple of years of elementary school. And his dream was to be a truck driver. And he became an assistant to a truck driver. And then he became a truck driver and was able to buy his own truck, and eventually became the owner of a trucking company. And he told me very proudly, all my children went to college. So it's like a wonderful story that shows that, really people can do anything if they set their minds to it.
Yeah, you were talking about this contact you had who had come out of England, and the person he knew there. You ended up in England, in Britain,
Yes.
to get both your bachelor's degree and on to your PhD, right? At University College London?
That's right, yes. I realized that, if I really wanted to work for NASA, which was my dream, staying in Brazil, I had a lot of limitations at the time. Things have evolved quite a bit down there, and now there is a good space laboratory and very good universities. But at the time, I thought that I should go somewhere else. And when I was 16, my parents sent me to England on it was to a school in England, so that my sister and I could spend a month there and just perfect our English. And I really fell in love with England. And so I decided I want to go to college there. And at the time, it was a lot cheaper for my parents to pay than the US. And also the US is so big, and I didn't know where to go. I had never been here. So I felt comfortable in London. So that's where I ended up, at University College London. And it was tough being in a foreign country at as a teenager still, and living there, and before email, before cell phones.
Sure.
And the course was very tough. The Brazilian education system is a bit more like the US, where you learn all kinds of subjects in high school. In England, they specialize early. So when they go to university, they've been taking 2 or 3 years of, math and physics if they're going to go to astronomy. So I was actually behind other people, and it was a foreign language. But, I struggled, but I managed to get through.
Yeah, it's a lot of challenges. You must have been pretty driven. I mean, eyes on the prize.
Yes. I think that determination is the most important factor. And I've seen that in my career. I have mentored a lot of people. I have hired people, and those who are really determined, are the ones who go farthest. A few years ago, I'm still very close friends with many people who did the astronomy degree with me. And we have some reunions, and I had been interviewed by the college newspaper, and I had a reunion, and, the guy who was the best student in the class, he really was a genius, but he ended up not, just getting a job, but not doing a whole load, never did a PhD. And he said, I read that interview, and I realized why you succeeded when many of us sort of gave up, is because you really wanted it. So yes, is determination, and maybe being a bit stubborn too.
I think they go together. So you went on to get your PhD, also at UCL, I think.
Yes.
What happened? Did you go directly from there to JPL? Or was there something in between?
No, I went to do my PhD, and I decided to do it in planetary geology because in my last year in college, that's when we actually had some choice of classes. Because again, the
Mm.
degree in England, it's not like in the US where you can take classes in different things. This distribution requirements they call it. You
Yeah.
study history or whatever. There it was very prescribed. It was, hard going, math, physics. But in the last year, we had a choice of some subjects within astronomy. And I chose planetary geology because I heard that the professor was very good. And indeed, the professor was very good. And it was actually funny because I had been in this class for about 3 weeks, I think. And then the professor didn't show up. And a postdoc showed up to give the class. And he said, oh, the professor is a volcanologist, and Mount Etna in Sicily erupted, and the professor had to go. And I thought, this sounds really exciting. Of course, I always had an adventurous spirit. So I enjoyed the class a lot, and I went to see him, and anyway, ended up doing a PhD with him. And as I was finishing my PhD, I realized that I had to get a job, and I had asked my parents to support me for long enough, and it was getting harder for them. Things were getting more expensive, and it was very, very difficult to get a postdoc in England at that time, so at least in my field. So I got a job as curator of modern astronomy at the National Maritime Museum. That's where the old Greenwich Observatory is.
I have been there. I've been to Greenwich
We
and
have,
toured, did a great feature there for planetary radio, and didn't get into the Maritime Museum. Unfortunately, I didn't have time, but next trip, I want to go in.
Right, but you got into the observatory.
Sure did. It was just, it was like a shrine. Yeah.
Yes, and that's where I worked for 3 years while finishing to write up my PhD, and a little bit later. And during that time, I had it was an amazing coincidence. I used to come to the University of London Observatory, where I, typed my PhD on a computer, but we didn't have personal computers. And I used to come on Friday evening and stay until Monday morning and just work on weekends, and even brought a sleeping bag, and I would sleep in my office. And I was there on a Friday evening, and a researcher from JPL, David Peary, called my advisor. And my advisor had gone home, and I answered the phone, and we had met, Dave and I, at a conference, and he asked, how you doing? And I mentioned that I was finishing my PhD, and what are you going to do after? I said, well, it's really hard to get a postdoc here. And he said, NASA has this postdoctoral program that is open to foreigners. And that's how I ended up eventually coming to JPL to do a postdoc with him. And then I had another amazing coincidence that a few months before coming to the US, I was invited to a conference in Arizona, and I decided to just take vacation, and I had no grant, but pay for it myself and do it as vacation. And it was a great conference. And when I gave my talk, I was sitting next to a young woman about my age, and after I sat down, she said, oh, that was really good, and introduced herself. And she worked at JPL. And we ended up having lunch together, becoming friends. And when I came to JPL, she introduced me to the Galileo team. And that's how I ended up with a job at JPL and on the Galileo team. So life is like a random walk sometimes, and things just happen, and I have great opportunities.
I'm not going to deny that life can be kind of random in its opportunities sometimes, but I also think that you can point to your capabilities and how you impressed people, because after all, those people, they could have met you, had lunch with you, talked with you on the phone and said, yeah, so what? And yeah, obviously not the right person for this opportunity. So clearly you presented yourself, whether you knew it or not, as somebody that they thought would make a good colleague, and boy, were they correct. How many years now? Pardon me for
JPL,
asking.
oh heavens, over 30 years at JPL.
And to go in as a member of the Galileo team, that pioneering spacecraft, the first orbiter of an outer planet, just what an opportunity. And yeah, it did have a few problems like that.
Yes.
That stuck antenna, right? Was that something that you actually had to deal with?
Yes. In fact, I was I was finishing my postdoc when the antenna, they didn't try to deploy it straight away. Galileo did a flyby of Venus, a gravity assist, and then flew by the Earth. And after that, they tried to open the antenna, and it didn't open. And I saw that people, really got down to business. No one took that as defeat. They figured out ways that they would try to open the antenna. And after a number of attempts, it didn't open. And then people did amazing reprogramming of the spacecraft. The spacecraft was already flying, and reprogramming the instruments, the software in the instruments in the spacecraft to be able to do data compression and data editing, and it was amazing what the team managed to do. And I think it was at that time that I already really loved JPL, but I felt this is the right place for me. People don't give up. There are problems, but they go and figure out a way around it. And we ended up doing so much science with Galileo that people are still analyzing the data now.
Wow, yeah. And a part of so many missions since then, some of which we might talk about. But I'm thinking in particular of this European Space Agency mission, JUICE, which is now on its way to Jupiter. In fact, I just read, it reminded me that it's going to swing past Earth next week as we speak, and probably test out some of its instruments, I imagine. JUICE, the Jupiter Icy Moons Explorer. I think I got that right. Aren't you part of that mission as well? Which it's not going to orbit Jupiter, it's going to orbit Ganymede, right?
Yes. It's well, I'm part of the instrument team. And I'm part of the camera instrument team, Janus. Unfortunately, NASA never funded the COIs on foreign instruments. So, this is kind of, well, who knows by the time it gets there. But
still going to be a while.
Yeah, it's going to be a few years yet, but it's been a kind of source of frustration for many of us that we helped to write the proposal. We were on the proposal, and and we're not funded. So I have coffee with a colleague from Arizona State University who is also on the team, and I say, well, these are the kinds of observations I think we should do at IO, but he actually does the work, and because I'm not actually allowed to work on things that I'm not funded for.
Well, at least you have someone's ear.
Yeah, exactly.
Which is handy.
And I think, well, now I'm a collaborator on the Juno mission, and Juno is getting great data of IO. So I kind of went back to my, origins, at JPL, which was Io. In the meantime, I worked on the Cassini mission and on Titan.
And I want to talk more about Titan and certainly about Io as well. But I haven't even mentioned yet that, I got to find the right spot here, with all of this other work, the actual science that you continue to do, you are Deputy Director for Planetary Science at JPL, NASA JPL. And well, I'll just read it from the bio. In her role, she oversees the planning of new planetary missions, their implementation and operations. We're talking about Psyche, Perseverance, the Europa Clipper that we're also excited about, due to launch in October, fingers crossed. Some of us hope to be there at the launch. I was going to say, I don't know where you find the time, but obviously you're pretty good at finding the time to get a lot of things done.
Yes, I'm a bit of a workaholic, I have to confess. We have a directorate where all these missions reside, if you like, and my boss, who is the director for Planetary Science, he does a lot of the overseeing more the what we call the implementation of the missions. That is the messy stuff. Europa Clipper is being built. When Psyche, he was for a time project manager for Psyche, then operations, it's easier, and I deal a lot with the we do formulation of new missions. Those are competed missions, like for the New Frontiers and Discovery Program, and instruments, and technology, and investments in science, internal investments. So there is a lot of work, but we also have extremely competent people. So it's not like you have to be, in the minutiae all the time. We have very experienced people and very competent people. I mean, the people at JPL, JPL's biggest asset. They are really fantastic, and they're so dedicated. And we have people from really all over the world. That's one of the fun things there.
And you know that we at the Planetary Society very, very much want to do our part to make sure that JPL can keep doing the great work it does and hang on to all of those great people in the face of budget challenges that come up on a regular basis. It's why the Planetary Society came into existence in the first place. So we hope that we'll be able to continue to do our part to hang on to those great colleagues you have at the lab. On to volcanoes. You got 71 that you came up with on Io. We'll come back to it. Do you have any idea how many you visited here on planet Earth?
Oh, gosh, I have a list somewhere, but several dozen. I know that I visited volcanoes on every continent.
Wow. Including Antarctica.
Yes. Yeah. I went to Mount Erebus in Antarctica. And I actually went on a trip sponsored by the National Science Foundation, which I took as a vacation. And I went with a space artist, Michael Carroll, who I think is well known to the Planetary Society.
You bet.
Yes. The NSF used to have I don't know that they do still, but they used to have a program called Artists and Writers. And I really wanted to go to Mount Erebus. And I thought first of a research project, but then I thought, well, people already, doing this, or they have done it, and then I heard about this program. And I thought, well, I have written books, including I had written one book and edited one book with Michael Carroll. And I called him up and said, how would you like to go to Antarctica? And I thought he was going to say, are you out of your mind? But actually he liked the idea. So we wrote a proposal, and the idea was to write a book, which we did. And he did paintings comparing features in Antarctica to features on other planets and moons. That's one of my books, and it was great fun.
And I hope I'm not imagining this, but didn't I talk to you and Michael? Maybe it was after you
I
or
think you
he
did.
got back.
Yes, yes, you did. Yes.
Yeah. And I looked all over today in our messy home library for my copy of Alien Seas, collaboration you did with Michael,
Yes.
who is such a marvelous artist, that the two of you edited, I guess, as well.
Yeah.
And I couldn't find it. I was going to hold it up, but anyway.
Oh dear. We also did. We wrote Alien Volcanoes.
Yep. Yeah.
First, and then the Antarctica book is there. Oh, there it is on the chat. Earth's on Ice World. Yeah.
She is so on top of things. That's Amber.
Yeah,
look at all these links.
It's a fun book, even if I say so myself.
It's a very fun book. Yeah.
It's including some. We put like diary entries, at the end because we both kept notes. And you see, I hate the cold. I hate the weather. I'm from Brazil.
But you went to Antarctica. Okay.
Yes, and I only went because there was a volcano there. And I will do things I don't like if there is a volcano there.
At least you could warm your hands over it, I suppose.
It was a lava lake in the bottom of a crater, so it wasn't that close, but we weren't that close, but at least on the top of the volcano, there was no snow because the ground itself was warm. So it was, yes, it was very nice.
Your JPL colleague, Ashley Davis, he was part of a panel that I had outside of Chicago for the Ravinia Festival. It's actually featured on this week's episode of Planetary Radio. And we got together to talk about the Moon's Symphony. One of the movements in that symphony by Amanda Lee Falkenberg is Io. But I was talking with Ashley. He was there. He had a wonderful video from his trip to Antarctica of a lava lake exploding. I think it was Erebus.
Yeah, that's the same one that I went. It's Monte Erebus, and it's really it's quite a spectacular place. And you can just go on the web and find lots of footage of Monte Erebus, and there are colleagues, including another colleague from JPL. Who have done projects in Antarctica for many years, and I was able to meet there, not on top of Erebus, but at McMurdo Base. Professor Phil Kyle, who was known as Mr. Erebus, and he's really quite a character.
Do you have a favorite volcano anywhere in the solar system?
That's very hard. I would say that on Earth, I have a special fondness for Mount Etna because it was my first volcano. I did a lot of field work on Mount Etna. But I must say a volcano I really, really like. And if people actually want to go and visit a volcano and see some activity in a safe way, or safe most of the time, actually Yazur volcano on Tana Island in Vanuatu, that's a great volcano to visit. And I've been there a couple of times, and it has strombolian eruptions and a strombolian activity. That the name comes from Stromboli in Italy, an island in the Aeolian Sea. It's small explosions, so you can watch them quite safely. And this volcano is great. You can drive almost to the top of the volcano, and then there are even steps that that you can get to the nice viewing point. And last time I was there, they even had a park bench.
Sit and watch the
You
explosion.
sit and watch the volcano erupting, and it's really great.
You know, for years, I've never been closer than I was about 3 months ago when I was in Costa Rica and I was at the foot of Arenal, I think it is. And there was some steam up at the top, but that's the closest I've been. I've always wanted to go somewhere, the big island of Hawaii or someplace where I could really get close and see some of this activity. And, you know, there is nothing like a volcano, I think, in terms of just natural phenomena, for just sheer fascination and lighting people's minds up, their imaginations. I think almost everyone must feel this.
Yes, yes, and I think volcanoes erupting. That's the most spectacular natural thing you can see, in my opinion. Now, volcanoes come in many different types. So, volcano like Mount St. Helens or Rainier, if they are starting to erupt, you don't want to be anywhere near them because they are extremely explosive and extremely dangerous. The volcanoes that are best to observe are the ones like in Iceland and Hawaii that have what we call Hawaiian or Icelandic eruptions. And then the Strombolians. Stromboli in Italy, again, you can hike to the top of the crater, and Yazur is even easier because you can drive almost all the way to the top. So it's my first book, in fact. It's called The Volcano Adventure Guide.
Yes.
And I wrote it because actually you interviewed me about that book many years ago. And I wrote it because I gave talks about volcanoes, and people would ask me, oh, how can I go to a volcano? How can I photograph a volcano? How can I be safe? So I decided to write that book because there were many books about volcanoes, but none that actually took that angle, how to go and visit a volcano safely.
I have to dig. That's another one that I had a copy of. I'll have to dig it out again because I'm going to make it someday. If you've joined us recently, you probably already know that we are talking to Rosaly Lopes of JPL, volcanologist, planetary scientist, and, as we said, the Deputy Director for Planetary Science at NASA JPL. Do we still have a lot to learn about Io, that most volcanic place we know of anywhere?
Yes, there is always more to learn. There is more to learn about the Earth. So it depends when you're formulating a mission. That is, when you are thinking of a new mission, what you want to get is the most science for dollar. It's I'm actually part of a study for a spacecraft to go and collect a sample from one of the Io plumes.
Wow!
And that's actually, we are finding, is quite feasible. But if you brought back a sample, that's really the only way you're going to know the composition of the magma. And it can also tell you a lot about how Io formed, because you're getting material from the interior, even about the formation of the Jupiter system. There are a lot of things that Galileo found out, and Juno is doing a spectacular job. Of observing Io with remote sensing, and also, gravity science.
Yeah. And JunoCam, that camera that was just supposed to be there to satisfy the public, which is doing such great science.
Yeah, that's right. I'm collaborating on a paper with the Juno Cam team. And I've been working for several years now with the GIRAM team, which is the infrared instrument on Juno. And again, Juno's had trouble with the radiation around Io. It's really not good for spacecraft, but we managed to fix things, and it's still getting great data. Now it's not going to do another close Io flyby, but there is a lot of data to analyze. Juno is one of these missions that it wasn't even supposed to look at the satellites, but in the extended mission, it's doing that. And then we're going to have JUICE, and JUICE is going to do some, not close, but some remote sensing observations of Io, and who knows in the future. But as I'm sure you know, every 10 years, planetary scientists get together. There is a committee put together by the National Academy of Sciences, and they come up with what's called the Decadal Survey.
Yes.
So that prioritizes the science we're going to do for the larger missions. For the small missions, like the Discovery program, it's still competed, and it's open to any place.
Let's move out a little bit. I mean, we could talk about Europa Clipper. We could say more about JUICE, talk more about the moons of Jupiter. We could talk about Enceladus, which has those plumes that we hope are going to be tasted or maybe landed among someday. But then there's Titan, which I think that's a place you're currently pretty involved with, aren't you?
Yeah.
And are you still? What is your affiliation right now with the NASA Astrobiology Institute?
Well, I was the principal investigator of NASA Astrobiology Institute proposal. In fact, the institute as such doesn't exist anymore, but the proposal got funded, and we kept going. And now it's been longer than 5 years. The proposal was for 5 years. But we obtained what's called a no-cost extension, which means you don't need to give us any more money. We still have some, but let us work for longer and use up all of these funds. And so I have still a large team working on the astrobiology aspects of Titan, we are finding exciting results, and I have started to write. It's going to be mostly a review paper, but a paper on the bringing together of these results from the team, because we had between co-investigators and collaborators, like dozens of people.
I had forgotten that the Astrobiology Institute basically was dissolved and its functions were kind of moved elsewhere across NASA. Yeah. But this is still so intriguing. I mean, as you look at the possibility or the habitability, let's say, of life on a world like Titan, are you looking at deep down where there may be a liquid water ocean, or up in that fascinating surface that is so Earth-like if you ignore the fact that it's so frigid? In other words, right. What people like to call life as we don't know it.
Right. We think that if there is life on Titan, the most likely place for it is in the subsurface ocean.
Yeah.
So our proposal did not focus on so much on the surface. We did study the surface because the idea is that first of all, you have to know what organic compounds Titan has. We know it's got organic compounds in the atmosphere, and we had a team studying atmospheric composition. And then other people studying how this material was falling to the surface, being transported across the surface. And I did a lot on the geology, including the first geologic map of Titan. We also used the spectrometer on Cassini to do a compositional map, but so there are lots and lots of organics on the surface.
Yeah.
But the question then was, how do these get into the ocean? Because if you can get organics in the ocean, then it's like getting food for any biology that might exist there. And that's something that we are a little bit stuck on, because we don't. Titan has this ice crust on top of the ocean, and it's quite thick, like maybe 70 kilometers, maybe 100 kilometers.
Wow.
So how do you break that ice crust and get material in the interior? Or, we didn't see fractures on the crust of Titan, not like Enceladus. And then it was another of these coincidences. A Brazilian professor got in touch with me, Professor Álvaro Costa. He's at the University of Campinas in Brazil, which is one of the top universities. And he said, I have a sabbatical coming up. My expertise are impact craters, mostly on Earth, but I would like to work more on planetary. And he said he had funds to come for a sabbatical. And I said, yeah, okay, I'm sure we can do something. And so what we ended up working on with several other colleagues was, could a large impact on Titan actually breach that ice crust and bring material from the surface to the interior, and from the interior also to the surface? And we found that, yes, it was quite feasible that would happen, at least with the largest impact. So we know that you can get organics into the ocean. There are also some organics that can get into the ocean from the material in the interior, in the core of Titan. So other colleagues worked on that. A question that's still kind of open is, can you get enough material? And I also collaborated with Catherine Nish, who is in Canada. She's also an expert on impacts. And, we had a paper that showed that, probably there haven't been that many large impacts on Titan. So could enough material have gotten into the ocean? And, it was a little bit iffy there, but there are a lot of assumptions we made, and it could be that in the ancient history that more impacts happened than we figured. But the mission Dragonfly is probably
that's where I was going next.
Is really going to analyze chemistry. So we'll see. It's life is such a mystery, and such an unknown, because the only place we have found life is on Earth. And I always had a problem with the Drake equation, because I think you can't do statistics on a sample of one. So when he gets to that last thing, I mean, how easy or how hard is it for life to start?
Yeah.
And that's what we don't know, and that's why it's so important, for example, that we bring samples back from Mars.
And how? They're sitting there waiting for us.
They're waiting. Yeah.
We are all, of course, looking forward to Dragonfly. Elizabeth Turtle, the leader of the Dragonfly mission at APL, was also part of my panel at the Ravinia Festival a couple of weeks ago. And boy, are we excited about that octocopter that we all look forward to having go there. I think about you being one of the first people when you were working on Cassini to see those radar images coming back of that marvelous, complex, diverse surface. And then, of course, those few wonderful images that came from the Huygens probe. I mean, what was that like to peer through those clouds for pretty much the first time, at least with any detail, and see this wonderful world that in so many ways, could remind you of Earth, except for the temperature?
Yes, yes, and that was the surprise about Titan. It's so Earth-like. For us geologists, it was amazing. I mean, you see mountains, you see features that at least many of us think are cryovolcanoes. So volcanoes, but different than the ones on Earth or Io. We see dunes, we see erosion by wind, we see lakes of liquid, only is liquid methane and ethane rather than water. So it's so Earth-like, and yet it's so alien. So and it was an incredible thrill because Titan had the largest, in terms of area, the largest unknown area in the solar system by the time Cassini got there. And seeing it for the first time, particularly with radar, when you could really see features. And our first pass showed a lot of plains because Titan has a lot of plains. And the second pass then showed these the dunes, but at the time we didn't know they were dunes. We saw those linear features, and someone said, "What are those cat scratches?" Because it really looked like a cat had scratched, and we have a lot of cat people on the team.
Yes, right.
And the funny thing that happened was we were having this. It wasn't a Zoom meeting, but it was like some telecoms with the team, and people are talking about cat scratches, and a week or two later, I was at my local supermarket on the checkout line, and then I see one of those, let's say fun newspapers, and it said giant cats found on Saturn moon. And I thought, was that us? Was someone listening in? Did someone? And they think it's really cats, but and for the first time in my life, I actually bought it. Like I have to.
You're allowed to buy one copy, yeah.
Yes, I have to see what this is, but luckily it was nothing to do with us. They said the Huygens probe had found the giant cats, and
I wish. It would be a cryo cat, I suppose.
Yes, cryo cats. Yes,
cat scratch fever, indeed.
But it really worried me for a minute,
I have so many more questions. We have already been talking for an hour. Do you have a few extra moments here?
I could do 5 more minutes. We could wrap up something.
We're not getting a lot of questions from other folks, but I do want to bring up some of the ones that have come through. And we've got a good crowd out there. Thank you for joining us and sticking with us, everybody. I know you're finding this as interesting as I am. Quite a while ago, there was a question from Robert. He said, what kind of telescope do you use at home? Do you own a telescope? And when you spent those long weekends typing away at the Greenwich was it the Greenwich Observatory or the Naval Observatory?
Yeah.
Did you do some observing?
Yes, actually, part of the reason I was hired there was because they have a really nice telescope. 28-inch refractor telescope is one of the largest refractors in the world. And so I worked with that on nights that we open to the public or to school groups. So I was like operated that telescope. But I don't actually ever had my own telescope. It's when I was, young, I wanted one, but they were really expensive, and my school had one, so that was good. But then part of the reason I got kind of a little put off from observational astronomy is that you had to spend a lot of nights in the cold. And as I told you, I don't like the cold.
Yeah, we've established that, right?
Yeah. So, I thought volcanoes would be warmer.
That's great. Here's one from John. Do you feel that the solar system moons that exhibit volcanism may indicate better chances of finding life, I assume, on those worlds? And I guess I would include in this, I hope John would too, the worlds that have cryovolcanism. I mean, I'm thinking of like the tiger stripes on Enceladus.
Yes. Well, the three ingredients that you need for life as we know it, water, energy, and organic material. And many of the icy moons, like Enceladus, Titan, we think now there are papers coming out that several other moons may have oceans under the ice crust. I mean, we know Europa, Ganymede, Triton, so if they have oceans, they have volcanism, they have organic material, it doesn't mean that life will necessarily be there, but those are the places that we would look for life. So now there is a lot of interest on Enceladus because, again, there is volcanism, the materials being spewed out, and also Enceladus is easy to sample material that comes directly from the ocean. So you don't have to drill, you don't, which can be very difficult, particularly kilometers of ice. So that is a major target from the latest decadal survey.
And the samples come right up to you, to your orbiter, as you fly through them, as they did with Cassini. Yeah.
Yes, but also Mars. In fact, the Sherlock instrument on Perseverance found evidence of organics. This is a very new result.
Yeah, yeah.
We knew that Mars had water in the past. We found those rocks. A sample was collected that is the best candidate to, that we might find life. I'm not saying we will. No one's saying.
Of course,
signature, but we should bring it back and really examine it.
Very, very exciting. I mean, it's just in the last few weeks that was unveiled.
Exactly, yes.
And my God, I hope that it appears to be regenerating or increasing, amplifying interest in getting those samples that are waiting there on the surface and inside Perseverance back here so that we can get them into the right labs. Let's see. Ernest asked, how can a mission on Titan find possible proof that Titan could have life on it? I'm going to say, Ernest, that we probably have mostly answered that. And we've got one other before I throw a last question at you. This was from David. I'll be taking the tour of JPL next week. Congratulations, David. Everybody should. I love every time I have gone to JPL, I have had the best time. Any particular sites at JPL that you enjoy most or maybe recommend? Maybe I'll get to meet you. I mean, there are a lot of people at JPL, David, but who knows? Maybe we'll get lucky. I mean, what would you want to see at JPL?
Okay, unfortunately, I'm going to be away next week, so I'm sorry. Otherwise, I would have made an effort to come out and, of my office, my little, my hole, and actually say hi. You really enjoy the tour. It's very spectacular. I'm not sure where the tours go exactly, but you certainly see the museum, and that has a model of Galileo, of the Galileo spacecraft. That if you go into the auditorium next to the museum, you see a Voyager model and
Full size.
yeah, full size, and the model of Cassini that's not full size because that
Right.
would be very big. Cassini was like the size of a double-decker bus. But the Galileo model is full size. And then you see there is one building that I'm sure you go in and you see a model of Perseverance full size. Yeah, I mean, that would be exciting. Mm.
Hopefully you'll make it into that gallery up high behind glass that looks down on the high bay, where so many of these explorers of the solar system have come together, including the rovers and so many more.
Yeah. Unfortunately, Clipper has already been shipped to the Cape. So
yeah. And let's hope it stays there and launches on time in October, and is very safe when it flies around, when it makes it out to Ganymede with those little troubling transistors that have been found. Rosaly, it's already now almost 10 minutes after. I just got one more for you, and that is about the work that you have done and continue to do to share what our boss, Bill Nye, calls the passion, beauty, and joy, making it out there to the public. You've already mentioned some of your books. This obviously seems to be very important to you, and I want to get your thoughts about that. But I also have to say, Sally Ride, one of my dearest friends and just heroes, wrote the foreword to Volcanic Worlds, the book that you mentioned a little while ago. And then, and with all of its chapters, because you did the editing, written by women, but then Arthur C. Clarke, James Cameron wrote the forewords to Alien Volcanoes, Alien Seas. And I'm proud to say that all three of those people were my guests on Planetary Radio. Sally was actually a regular contributor, participant in Planetary Radio for a while. What an honor to have had people of that caliber who wanted to be a part of your efforts to share the PB&J, the passion, beauty, and joy, with the public. I mean, why is this so important to you?
Because I think the greatest reward that I can have is to inspire other people, particularly the younger generation. And I have been so moved when young people have come to me and said, I saw you on a documentary, or I saw you on a NASA video, and and told me that I inspired them. The other day I had a message on LinkedIn from a Brazilian, a man, I assume a young man, and he told me that he grew up poor and his family didn't have internet at home because, they couldn't have it. And he used to go to the library and go on the internet, and he found my story, and he was so inspired, and he really worked hard. And he wanted to let me know that he had just finished a master's at MIT in data science.
Wow.
And he was going to start a PhD at the University of Cambridge in England.
Oh my God.
So things like that, make it all worthwhile. And I do a lot of online activities with Brazilian students, and go there once or twice a year, because a lot of the time they have far less than the students here in the U.S. do. And we have to inspire the people who come after us. Any science work we do, it's only a small bit, and that hopefully will serve to bring science forward, but it's the people who come after us who will move the science forward.
Rosaly, may you continue to discover and inspire. Thank you very much for all of this work you have done for years, and all of the service that you have provided to our society, the Planetary Society, and of course for, spending almost an hour and a quarter now with us this evening as one of our planetary people. Thank you so much. It is truly an honor to know you, and I look forward to crossing paths again soon.
Thank you very much for having me.
You bet. And for the rest of you, again, thank you for joining in. And if you're watching us live, you are by definition one of the people who makes all this possible, because you are a member of the Planetary Society, which is why you're here in the member community. And for those of you, again, who are catching us on the website after the fact or on our YouTube channel, we welcome you. We thank you as well. Take a look at planetary.org/membership or /join, and I think you'll see that we offer a lot more than just access to the member community, but this is a pretty nice perk to be able to participate this way. And I will remind everybody, I think I might be able to reach it. Yep, there it is. We will be back with you live as we continue the Planetary Society Book Club on September 2nd, when we will welcome Chris Carberry, who will talk about his latest book, The Music of Space. My wonderful camera is fuzzing it out for us. Scoring the Cosmos in Film and Television. Chris Carberry, the founder and president, or actually executive director of Explore Mars, the people who put on the Humans to Mars Summit every year. That will be at 6 p.m. Pacific on September 2nd. And it's a fascinating book. I'm having to stop as I read it and dig the music out of YouTube or wherever so that I can see what Chris is telling us about. Absolutely fascinating. Thanks again, everybody. And Rosaly, one more time, thank you to you as well. Take care. Bye-bye, all.